Let's acknowledge what you are doing right now. You are staring into a glowing rectangle, whether it's the phone in your hand or the monitor on your desk. This specific geometric shape has defined our digital existence for the last 40 years. Think about how you naturally operate. You move in 3 dimensions. You use both hands to grab, rotate, and manipulate objects. But traditional software took those natural movements and flattened them. We were forced to squeeze our actions into 2-dimensional constraints, relying on abstract tools like drop-down menus and scroll bars. Human life isn't rectangular. We look around, we walk, and we interact with physical space. We have pushed the physical and interactive limits of what a flat sheet of glass can achieve. We are watching the screen era end. Technology is moving out of the monitor and into an age of spatial computing, where digital tools break out of the frame and become an ambient part of the physical environment. This transition isn't about a new hardware trend. It's about building technology that finally matches the way our eyes, hands, and bodies actually function. The history of computing is a long trajectory of shrinking the distance between what we want to do and how the machine responds. During the desktop era of the 80s and 90s, the friction was high. You had to sit at a stationary machine and translate your thoughts into the computer language of typed commands and folder clicks. In the 2000s, the computer moved into our hands. The abstract mouse pointer disappeared, and our own fingers became the tool that directly manipulated icons on a screen. By the 2010s, devices began using GPS and cameras to see and locate themselves. This allowed apps like Pokemon Go to begin mapping digital content onto the real-world environment around us. Each of these stages stripped away a layer of friction. Now, the rectangular screen is the final barrier left to be removed. This leads us to spatial computing, software that maps the 3-dimensional geometry of your room. It operates on a spectrum. Virtual reality replaces the world. Augmented reality overlays digital information, and mixed reality allows digital and real objects to interact. But if you take away the keyboard, the mouse, and the glass touchscreen, how do you actually click on anything? We use a new vocabulary of natural inputs. We use voice for conversational computing when our hands are busy, and gesture control, where cameras track our fingers so our actual hand becomes the mouse. We use gaze tracking, where our eyes acts as the cursor, and body movement, where simply walking through a room becomes the way we navigate an interface. By utilizing these biological signals, the machine is finally adapting to our language rather than forcing us to learn its own. When you break the rectangle, you move from watching a 2-dimensional representation to physically experiencing a 3-dimensional model. Consider a medical student. A flat textbook diagram requires them to imagine depth and scale, but dissecting a floating 3-dimensional anatomical model that can rotate and walk around provides a spatial understanding that a screen can't match. This logic applies everywhere. An architect can walk inside a digital hall before the building exists, and a retail customer can place a life-size chair in their room to see if it actually fits the space. The software is shifting from a tool we look at to an environment we inhabit. History shows that whenever we change the primary way we interact with computers, the job market follows. The desktop era required software developers. The mobile era needed app designers. Now software moves into 3D space where demand is shifting towards XR designers and 3D simulation artists, people who can build for depth instead of just length and width. The ultimate goal of technological evolution isn't to build a better, sharper screen, but it is to eliminate the screen entirely. In the past, humans had to enter the computer's world through a glass window. Tomorrow, the computer will enter ours.